Rakesh Chaubey from Sunbeam Sun City. My dear, today I am uploading, this is the last lecture on the first topic, that is physical world, and the last two laws, my dear. One is the law of conservation of mass and other is the mass energy equivalence law. Now my dear, you all know that I heard from you all in class 10th also, most of the student aware about that you must be knowing Einstein theory of relativity. And in theory of relativity, Einstein sir told that mass of the object or mass of a body is keep changing. Matlab mass will not remain constant. And but my dear, before Einstein theory, there was Einstein theory, before Einstein theory. So here I am writing before Einstein theory of relativity. बात को समझिए आप लोग. That is relativity की theory में, Einstein theory relativity में ये बोला गया that mass is not constant. Mass is keep on changing. When the mass of the body is not constant, I'll give you a little idea. When the body का speed, when the speed of that body is compared with the speed of light. I repeat in short, when the speed of the body will compare with the speed of light, then the mass will remain, mass will not constant, it will keep changing. Am I clear? But my dear, before Einstein theory of relativity, we have to say that there is law of conservation of mass. And therefore your NCERT book has said before Einstein theory of relativity. Now I hope you understood why the word given before Einstein theory of relativity, there is law of conservation of mass, because Einstein theory of relativity aane ke baad we came to know that, oh God, mass is not conserved. Mass will keep on changing. Not conserve matlab initial mass is not equal to final mass. It will keep changing. But in theory of relativity, Einstein sir has told us why, when it will keep changing, when the speed of that object, when the speed of that body will start comparing with the speed of light, then the mass will change. Okay, otherwise mass will not change. So mass is changing only in the theory of relativity. Rest all time we say mass remain constant. So when we are not studying this theory, and therefore the science said before this theory. So before this theory, law of conservation of mass is existing. And my dear, today also I can say, if I overlook this theory, if I overlook theory of relativity, we all can say mass is conserved in the universe. Okay, so now it's our duty to understand how the mass is conserved, how the initial mass is equal to final mass. Now my dear, take an example of chemical reaction. I am taking here example. In chemical reaction, everybody know chemical reaction. Please try to understand. In chemical reaction, for example, I am taking some chemical reaction. A plus B gives C plus D. What is A plus B? It is, my dear, everybody know reactants. And what is C plus D? Everybody know, it is called productants. My dear, try to understand what the science is saying, that in the chemical reaction, at the end, when chemical reaction is completed, right? Please take care of this example. Okay, I have written one chemical reaction, A plus B giving C plus D. When this chemical reaction is complete, when it will be get completed, then what at the end observe that that is mass of reactant is equal to mass of productants. Oh God, so nice it is. If I said mass of reactant and mass of productant are equal, you can say mass is conserved. The total mass is remain constant. Here also I can say mass can neither be created nor destroyed. The total initial mass is equal to total final mass. So my dear, this is the problem here. One doubt. What is doubt? Sir, when chemical reaction was taking place, don't you think the mass will change? No, my dear. I written here, mass of reactant and mass of productant is same. So sir, what is happening? My dear, I think during chemical reaction only there is atoms arranged. What takes place when reaction is taking place? Sir, atoms get rearranged. You can say atom get rearranged among molecules. Only there is atom rearranged among molecule. Their mass is remain constant. Their mass is remain constant. That is, mass of reactant and mass of productants are remain same. इतना केमिकल रिएक्शन हो गया, पूरा एक केमिकल रिएक्शन हो गया, वाटर किसी से ऐड हो गया, दूसरा एक प्रोडक्ट मिल गया. बट माय डियर, इन दैट केस जब वाटर किसी से ऐड हो रहा है और दूसरा एक प्रोडक्ट दे रहा है, मास ऑफ दैट वाटर विच इज एडेड टू सम अदर कंपाउंड एंड द आंसर, द प्रोडक्ट का मास इज रिमेन कांस्टेंट. यू नो why it is happening? Sir, during chemical reaction खाली atom rearrange होता है among the molecules. Please take care of this line. Only there is atom rearrange among molecule. Their masses remain constant. Am I clear, my dear? There is no change in the mass. Only there is a rearrangement of atoms takes place among molecules during chemical reaction. So the science observe this. The mass, for example, in my body, if chemical reaction is taking place, remember this, during that chemical reaction, whatever be the mass of the reactant, it will be the same as the mass of the product. Even chemical reaction will be over also, get over also. So in entire chemical reaction, only the atom get rearranged. जो पहला atom यहाँ वहाँ arranged थे, they get rearranged because of reaction. They get rearranged among different molecules, but mass is remain constant. So this is, my dear, the law of conservation of mass. If you wish to write anything from here, please write down. So again, take care of this. Sir, in the universe, before Einstein theory of relativity, because after relativity, everybody understood that mass is not constant, right? But before Einstein theory of relativity, my dear, the universe says, everybody used to say, the mass is also conserved. It remains same, because if any reaction takes place, am I clear? So no doubt the reaction is taking place, A plus B giving C plus D. Okay, the A is adding to B and giving new compound C and D. Okay, agreed. But in that sense, the mass of A plus B and the mass of C plus D will remain same. I hope it is going on with your chemistry chapter also. Mass of this and mass of this will remain same. So sir, फिर होता क्या है reaction में? खाली atom का rearrangement होता है among different molecules. Okay, so please write it down, and then I will go for the last law, that is law of equivalence between mass and energy. Please, thank you. Now my dear, let's begin with the last law, that is law of mass energy equivalence. My dear, law of mass energy equivalence, very fabulous with the equation E is equal to mc square, where E is energy, m is mass, and C is speed of light. And this formula was given by according to Einstein theory. So according to Einstein theory, my dear, we have to say E is equal to mc square. This formula is there, and this formula is given by Einstein theory. And what Einstein sir has said, according to this formula, my dear, what is happening, and let me tell you, this is happening in the nuclear process. In nuclear process, I have done in the weak nuclear force, strong nuclear force. In nuclear process or in nuclear reaction, my dear, try to understand क्या होता है न्यूक्लियर प्रोसेस के अंदर. ये आप देखेंगे कि क्या होगा, एनर्जी इज कन्वर्टेड इनटू मास, राइट? आई राइट हियर, मास इन न्यूक्लियर रिएक्शन और न्यूक्लियर प्रोसेस, मास गेट कन्वर्टेड इनटू एनर्जी और vice versa. What is vice versa? Mass get converted into energy, or you can say energy get converted into mass. Okay, and look at this, what is happening, sir, how this is happening. And my dear, this entire thing, this conversion of energy into mass and mass into energy are used in the nuclear reaction as well as nuclear process. This process was used in atom bomb, or you can say nuclear explosions. In all nuclear explosion, the energy is converted into mass or the mass is converted into energy. And what is happening in such process, my dear, I will tell you in small line. My dear, you must be knowing, when I said the word nuclear process, of course there will be two very important particles will come under the picture, elementary particles. Because I told you, neutron, proton, electron, they all are called elementary particles. So my dear, when this nuclear process was going on, there are two very important elementary particles. They are neutron and proton. So what is happening during nuclear process? The neutron itself converted into proton, or proton itself converted into neutron. We are not going in brief of this nuclei, because we will talk all this in as you will become more matured and we will go in class 12. But remember this, I am giving you little story कि न्यूक्लियर प्रोसेस में ना न्यूट्रॉन इटसेल्फ अपने आप प्रोटॉन में कन्वर्ट होता है. तो जितना मास ऑफ न्यूट्रॉन, ट्राई टू अंडरस्टैंड, देखो ये लैंग्वेज, जितना मास ऑफ न्यूट्रॉन प्रोटॉन में कन्वर्ट होगा उतना एनर्जी रिलीज होगा. Similarly, proton itself converted into neutron. तो जितना मास ऑफ प्रोटॉन न्यूट्रॉन में जब कन्वर्ट होते रहता है ड्यूरिंग प्रोसेस, the energy, equivalent of energy get released. So easy. And therefore science says that in this process the mass get converted into energy or energy get converted into mass. Okay, so my dear, I hope you all understood. Please take care of this topic once again. Look at it, what I said. In Einstein mass energy equivalence, this is the Einstein according to theory of that, E is equal to mc square. Where E is energy, m is mass, c is speed of light. Okay? Now my dear, what is happening in nuclear process or in nuclear reaction, please take care. Nuclear process and nuclear reaction में, sir, neutron itself, I'm not discussing कैसे होता है, but यहाँ पे सुन लो पाए, that neutron itself converted into proton. अब जितना mass of neutron proton में convert होगा, ये जब convert होते रहता है, energy release होता है. So जितना न्यूट्रॉन का मास प्रोटॉन में कन्वर्ट होगा उतनी ही एनर्जी रिलीज होगी. और उल्टा भी बोल सकते हो, द प्रोटॉन इटसेल्फ कन्वर्टेड इनटू न्यूट्रॉन, प्रोटॉन भी न्यूट्रॉन में कन्वर्ट होता है. सो जितना मास ऑफ प्रोटॉन न्यूट्रॉन में कन्वर्ट होगा, जितना मास ऑफ प्रोटॉन न्यूट्रॉन में कन्वर्ट होगा उतनी एनर्जी रिलीज होगी. इसीलिए बोला गया कि मास इज कन्वर्ट इनटू एनर्जी. So my dear, take care of this word during nuclear process. If anybody will ask you, please say this is a golden line. During nuclear process, the neutron gets itself converted into proton. And equal amount of mass is converted into energy. जितना mass of neutron होगा वो total का total energy में convert हो जाएगा, because neutron का transformation proton में हो रहा है. तो एक process हो रहा है और वो process में जितना मास ऑफ न्यूट्रॉन प्रोटॉन में कन्वर्ट हो रहा है उतनी एनर्जी रिलीज होगी. उल्टा भी बोल सकते हैं कि प्रोटॉन भी न्यूट्रॉन में कन्वर्ट होता है. So जितना mass of proton न्यूट्रॉन में कन्वर्ट होगा, राइट ड्यूरिंग द न्यूक्लियर प्रोसेस, उतनी एनर्जी रिलीज होती है, बिकॉज प्रोटॉन का ट्रांसफॉर्मेशन हो रहा है न्यूट्रॉन में. प्रोटॉन gets converted into neutron. And my dear, why this neutron and proton gets converted? Because in the atom, unfortunately, they are in, say, if I say one atom, there the proton is in the maximum number than neutron. Try to understand. कैसे होता है ये? मान लो कोई मैंने एटम लिया, कोई एटम लिया और मैंने बोला ये एटम में यार नंबर ऑफ प्रोटॉन ज्यादा है एज कंपेयर टू नंबर ऑफ न्यूट्रॉन. तो होगा क्या, साइंस क्या बोलता है कि अरे यार इधर नंबर ऑफ प्रोटॉन न्यूट्रॉन से ज्यादा है ना, तो कितना न्यूट्रॉन कम है, बिकॉज एटम को तो इक्वल प्रोटॉन और न्यूट्रॉन चाहिए, बिकॉज एटम नीड इक्वल प्रोटॉन एंड इक्वल न्यूट्रॉन. बट आई सेड सर्टनली एक एटम में सपोज अनस्टेबल अगर एटम है, अनस्टेबल न्यूक्लियस है, सो अनस्टेबल में नंबर ऑफ प्रोटॉन एंड नंबर ऑफ न्यूट्रॉन कभी इक्वल नहीं होगा. तो मान लो अगर प्रोटॉन का नंबर ज्यादा है, न्यूट्रॉन का नंबर कम है, तो अब दोनों को इक्वल करने के लिए प्रोटॉन विल कन्वर्ट, बिकॉज प्रोटॉन ज्यादा है और न्यूट्रॉन कम है, तो प्रोटॉन इटसेल्फ कन्वर्ट इनटू न्यूट्रॉन, है ना. तो प्रोटॉन जब न्यूट्रॉन में कन्वर्ट हो जाएगा, सो देन नंबर विल गेट बैलेंस. एक्सेस प्रोटॉन जो था वो खुद न्यूट्रॉन में कन्वर्ट हो गया, तो जो न्यूट्रॉन की कमी थी वो कवर हो जाएगी. आई होप इट इज क्लियर. एंड ड्यूरिंग दिस कन्वर्जन, when this conversion, vice versa also, if I said in one atom it is unstable, where number of neutron is more than number of proton, in that case what will happen, number of neutron ज़्यादा है, number of proton कम है, हमको दोनों को equal करना है, so number of neutron will get itself converted into proton. And when it was happening and when they become equal, my dear, in this process energy is released. So जितना मास ऑफ न्यूट्रॉन प्रोटॉन में कन्वर्ट हो रहा था या जितना मास ऑफ प्रोटॉन न्यूट्रॉन में कन्वर्ट हो रहा था, उतनी एनर्जी रिलीज होती है. दिस वाज हैपनिंग इन एटॉमिक बम, in nuclear explosions. This process is happening in atomic bomb or nuclear explosion. That's all. Thank you very much. Afterward, if time permits, today only I'll upload the video of the measurement. Otherwise, tomorrow you will get the video on the topic, the second chapter, measurement. Right? That's all. Please, my dear, it's my humble request. Today we have completed with the first chapter. Now, my dear, my request is, looking to my YouTube video, please make one proper notes. And afterward, when school will be reopened, please you can show that notes to me and you can work on that notes. Please start studying in a good manner. Every time only study and study. That's all. Thank you very much. Take care of yours. Thank you very much.